Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now we are solving this particular paper. That's an S1 paper. It's from May-June 2025 and the variant is 53. Yes, I'll also be solving some P1 papers. I'll just be uploading an M1 paper and so on. So let's get started. It's a walkthrough solution, so it would take around like half an hour. Now, question number 1, it says find the set of values of x. For a set of values of x, it is found that this data is given where k is a constant. Now, what is this question all about? This question is about coding. This is about assumed mean, where you do some subtraction. You subtract a constant value from each of your values of x, and then you gather this data. This is called summarized data. So the very first thing that you need to do is to realize that this thing inside, that is y. And now the information is sigma y is this thing, sigma y square is this thing. The value of n is 40. And all your working will be based on the variable y. So y bar sigma y over n, that is an exact value 20.9. So let me write over here, this is exact, it's not a rounded off value. So now how is y and x, they are related? If y is x minus k, y bar is x bar minus k. So now this value, given that the mean of these 40 values is this thing, this is corresponding to x. So therefore, x bar is 124, y bar is 20.9. So we find the value of k, which is 103.1. That is the first part. What about the standard deviation? Standard deviation for x and standard deviation of y is the same, because when we subtract something, or for that matter, if we add something, the standard deviation remains unchanged. So the formula that I write it for variance, st square. Let me just double check one thing. That is the voice is all good, all clear, and the recording is on. So I'll write this thing, st square for the variable y. It's sigma y square over n minus y bar square. We plug in all these values and we get this answer. So work in at least 4 significant figures. So 5 is also good. Therefore, when I take the square root, this answer is 3 significant figures. And let me write over here, standard deviation of y is the same thing as standard deviation of x. That is how this is also done. So 2 marks for the first part, 2 marks for the second part. That's 4 marks. Question number 2. So now it says, at a large college, all students who study science also study exactly one of art or drama or music. So art is in red color, drama is in blue color, music is in green color. What is the probability of people who studying art? That's 20%, drama 45%, music 35%. So make sure that your data is all aligned. You don't mix it up. You don't read it like this, art 45% or drama 35%. No, that is why I'm doing this thing. Of course, in the exam, you can use some underlining. First part, 3 students are selected at random. The people who are studying science, that is technically our class. And from them, the different percentages are given. So 3 students are selected. Find the probability at least one of these students studies drama. So the probability of success is the probability of studying drama. That is this blue color probability, which is 0.45. And 3 is the number of trials. And then we calculate probability x is greater than or equal to 1. That is 1 minus probability x is equals to 0. A very, very famous relationship. So that is 3c0. Success raised to power of 0. Let me highlight success in blue. Success raised to power of 0 and failure raised to power of 3. You write this thing because this was so obvious. That is why this is 1, this is 1, this is 0.55 cube. And then you round it off. You can also leave the answer in fractions. Fractions are exact. Fractions are beautiful. Now, second part is also binomial. 10 students are selected at random from the students who study science. Find the probability more than 7, that is greater than 7, study art or music. So that's a new category, art plus music. Art is 20%, music is 35%. 20 plus 35 is 55%. That is your probability of success. 10 is the number of trials. So 10 is the number of trials that goes over here. And then probability x greater than 7. So you need an inequality greater than 7. 7 is not included. So write over here 8. That is 8. That is 9. That is 10. So you have to add all these probabilities. Look at all my working. You have to show all the necessary steps. So first of all, let me again highlight this thing over here. That this thing, let me choose this one. So over here, if I choose this thing over here, that is this probability. If I choose this thing over here, that is this probability. If I choose this one over here, so that is this probability. Got it? So that's how you should write it. Of course, how many significant figures are there? One, not this thing. That is 1, 2, 3, 4. I think 4 is more than enough. So I wrote these answers from the mark scheme. So I picked it up from the mark scheme. That is the maximum that they have written. And then the very final answer that you will be writing, that should be given correct to 3 significant figures. So that is this thing. So 2 mark for the first part, binomial, 3 mark for the second part, again binomial. So this thing is done. Question number 3. Now, this looks like a question of geometric. And the last part was a tough one. So now over here, it says a fair six-sided dice with faces numbered 1, 2, 3, 4, 5, 6. It's a fair die. All the probabilities are 1 over 6. It's thrown repeatedly until a 3 is obtained. Until, that means it's a geometric probability distribution question. So this is geometric probability distribution scenario. So now when this is the case, the number of throws, not toes, taken is denoted by the random variable x. So first of all, define the distribution like this. So it's about getting a 3. Probability of success is 1/6. Probability x is equals to 8. That means there will be 7 failures. 1, 2, 3, 4, 5, 6, 7. The probability of failure multiplying by itself 7 times, that is 5 over 6 raised to power of 7. And there will be 1 success. I have written the answer in fraction. I have written the answer in decimals. The next one, probability x is less than 9. A very, very important concept that always comes. So let me write it over here. This one and the other one also. So first of all, let me write this thing. That is probability x is lesser than or equal to n. That is 1 minus q raised to power of n, where q is the probability of failure. P is probability of success and q is probability of failure. So less than 9 has to be converted to less than or equal to 8. And there is also another one, that is probability x is greater than n, that is q raised to power of n. The pink one is the examiner's favorite. So probability x is less than or equal to 8, 1 minus probability of failure, 5 over 6 raised to power of 8, and that's the answer. Now, this particular thing, there are some questions. Do check it out. I think it's in the year 2024, and it's in at least 2-3 variants. A question similar to this, not exactly the same, but similar to this. Over here, they are saying this thing, that find the probability that a 3 is obtained for the second time before the 6th throw. So there are different ways of doing it. I just expanded it and then I have done it. Now, before the second throw, it could mean we are talking about 5 throws, 4 throws, 3 throws, 2 throws. 1 throw is not possible because you are getting 3 2 times. Now, first of all, the first thing is, if we are talking about 2 throws, the second one has to be success. If we are talking about 3 throws, the third one has to be success. If we are talking about 4 throws, the fourth one has to success. 5 throws, the fifth one has to be a success. So now this particular part, this is like geometric probability distribution. So this one and this one and this one and this one, that is geometric probability distribution. But what about the parts before that? This part, or for that matter this, or for that matter this, or for that matter this is binomial. So this one is binomial. So it's a combination of binomial and geometric. And keep in mind, it's for 3 marks, so try your level best. And this was the only tricky question over here. So basically what I've done is that If 1 is success, naturally I could have just directly written 1 over 6, but I want to develop a binomial scenario. So this is 1C1, success raised to power of 1, failure raised to power of 0, that is binomial, and this is success on the second throw, the second time. Out of 3, this is the third success. Therefore, out of these two, I write 2C1, success raised to power of 1, failure raised to power of 1. Out of 4 throws, the fourth one is success. So therefore, from these 3, I just need one success, and that could be in any order. So that is 3C1, success raised to power of 1, failure raised to power of 2. Similarly, for 5 throws, what is success? The fifth one. Therefore, out of the first 4 throws, I need only one success. And then you add it all up, either this or this or this or this. That's the answer in fraction. That's the answer in decibels. So this part, I agree with this. This was a very tough part. So this was very tough. But again, go to the 2024 papers. You will find similar questions over there. Now, question number 4 are pretty basic stuff from descriptive starts. 84 people attempt a particular puzzle. The time taken to complete a puzzle are recorded. The times are represented in the CF curve. Now, don't be misled by this thing. This number is misleading because someone might think that that is the total cumulative frequency. The total cumulative frequency is 84. It ends over here. This is corresponding to 84. That is the ending. That's the total number of people. Now, the first part is use the graph to estimate how many people took between 4 and 7.5 minutes. So now if I look at part A, so this is 4. This is for part A. This green highlighter is also for part A. Technically, if I go to 4 minutes, read of this value, that means 25 people are taking less than 4 minutes. So therefore, let me write over here, 25 people are taking less than 4 minutes to do the task, which is completing this puzzle. And then when I go to this one, 7.5 minutes, this corresponding value is 69. This is just an approximate number. So 69 people are taking less than how many minutes? 7.5 minutes. So they are asking how many people took between these two values. So this is 25, this is 69, subtract. So when I subtract, I get this answer as 44. So that is how this working is technically done. Got it? Now the next one. It says on the grid below, draw a box and whisker plot to summarize the information in the CF curve. Now, when this proper name is box and whisker plot, in short, we call it the box plot. That is a 5-point summary. And what do we need in this 5-point summary? We need LV, that is the lowest value. We need HV, that is the highest value. We need lower quartile, we need median, we need upper quartile. So over here, the lowest value was very obvious. The lowest value is 2. The highest value is 12. That's where the data is ending. And then for lower quartile, median, upper quartile, what do we do? So this is 1/4 of 84. That's 21. We go to 21, read of the value. For median, that's half of cumulative frequency. Half of 84 is 42. We read off this value. So that's 21. That is 42. And this one is 63. Let me mark it. This is 63. And we are looking for the upper quartile. So now the working is shown over here. Half of 84 is 42. 42 from the y-axis is giving me the median value on the x-axis. So now the y-axis is giving you x-axis. Y-axis 21 is giving you 3.7. Y-axis 63 is giving you 6.6. So now there are 5 values that we need. We need 4.8, that's the median value. We need 3.7, that is the lower quartile. We need 6.6, that is the upper quartile. We already have this value, lowest value and highest value. So I have drawn a grid over here and I have labeled it like this. That is the linear scale. And what is the linear scale about? That is the time in minutes. So time in minutes. And there are 5 dots that I have marked. So therefore, the median value is 4.8. That is this one. This is 3.7. This is 6.6. This is 2. This is 12. And let me do some construction over here. That is to draw a box. The thickness of the box does not make any difference. So let me choose this color and let me choose a thin one. So it should be a little bit like this. And as such, the thickness doesn't make a difference like this. And let me draw it like this. And that's how the box is created. And there are 2 whiskers. So this is one whisker and this is the other whisker. So that is the box plot for this. So all got all done. Question number 5. Again, a nice question. We have seen questions like these before. Bag A contains 6, 5, and 1 red, blue, and green respectively marbles. Bag B contains 5 and 3 blue marbles. A marble is chosen at random from bag A and placed in bag B. So now what's the first thing? The first thing is 6 plus 5 plus 1. How much is that? The total is 12. This is bag A. And over here, the total is 5 plus 3. So total is 8. But then you are getting 1 from the transfer. That is bag B. So now the total will be 9. So I just wrote by mistake 9 because I was thinking of 9. So this is technically bag B. Is this all good, all clear? So 8 were there originally. That is this and this is 8. And then you added 1. So now when you are drawing the tree diagram, you have to be very careful. So this is the first pick. This is the second pick. There were 3 colors. That is red, blue, and green. Do not reduce the probability. This is 6 out of 12, 5 out of 12, 1 out of 12. And then over here, first write the original thing. That's 5 out of 8, 3 out of 8. 5 over 8, 3 over 8, 5 over 8, 3 over 8, and so on. But then you increase 1 in the denominator. So 1 is increased over here. When you take out red, and then you are picking from bag B. So first pick is technically bag A. And let me just reduce this or remove this. So this is bag A. And this one is bag B. So now what is happening is that this 6, 1 red is transferred. So therefore the number of reds are increasing. 5 plus 1 is 6, 6 over 9, 3 over 9. Yes, in this tree, it's adding up to 1. That's another quality of tree diagram. When blue is transferred, 3 plus 1, that's 4 over 9. This is 5 over 9. This is perfect. And this was totally brand new. Brand new in the sense that there were no green things over here. But when you are transferring, of course, there should be 1 green over here. So this is 1 over 9, and extra branch is being added. So that was brand new, what we have seen. So that new green branch was added in bag B. And that kind of scenario, we have never seen it before. But I mean, nothing special. Of course, it should add up to 1. So this was 5 over 9. This was 3 over 9. That's 8 over 9. That means 1 over 9 was the missing piece of the puzzle. So therefore, a line is drawn over here. So I hope this thing is clear. That is 3 marks for this thing. Now it says find the probability both marbles chosen are of the same color. It could be red, red, or it could be blue, blue, or it could be green, green. So double check over here. When we talk about red, red, that's 6 over here. 5 plus 1, that's 6. Blue, blue, 5 from here. And blue is 3 plus 1. And green, 1. And then green, 1. Double check. So that is 6 into 6. That's 5 into 4. That's 1 into 1. So now look at the color combo that I'm writing. This is for red, red. This is for blue, blue. This is for green, green. All together, this adds up to 57. The denominator is 108. You can leave it as in the exact form, or you can reduce the fraction. Do not involve decimals over here. Now, conditional probability question. Find the probability marble chosen from bag A is blue, given the marble chosen from bag B is blue. So whatever comes after the word given, that is the condition. Given that the marble chosen from bag B is blue. So that means it could be, let me write over here, red, blue, or blue, blue, or green, blue. That is the uh, denominator. So given that becomes the denominator of the conditional probability thing. So now over here, 6 into 3, that is 18. 5 into 4, that is 20. And 1 into 3 is 3. This is the reduced answer that is written over here. So now it says, let me write the unreduced one. That would be better. So therefore, let me write over here. This is 12 into 9, 108 as before. That is 18 plus 20, 38. 38 plus 3, that is 41. So this is 41 over 108. So now this is, let me write over here, 20 over 108 divided by 41 over 108. That is 20 over 41. That is the answer. And then what is the numerator? The numerator is the marble chosen from bag A is blue, given that the marble chosen from bag B is blue. So blue, blue goes the numerator. So blue, blue, this is blue. This is blue, this is blue, that is the numerator that goes at the top and the condition goes down. That is how you divide and then you get the answer. Question number 6. Now it says a company sells bags of pasta and then it says the masses of large bags of pasta are normally distributed with mean such and standard deviation. First part, find the probability the mass of a pasta in a randomly chosen large bag is less than 2.65. Basic working, the 7 rule working. First of all, make sure you write this thing down. Make no mistakes. Probability x is lesser than 2.65. Standardize it. Subtract the mean, divide by standard deviation. You get this value. When you get this value, go to the z table. And this is rule number 1. That is just direct reading. And then you read of the value. Don't forget to take care of accuracy. 0.894, correct to 3 significant figures. That is the first part. Now, the second part. What is the second part? The second part is a restaurant manager buys 160 of these large bags of pasta. Find the number of bags. That means the expected value. They also use the word expectation. Find the number of bags for which you would expect the mass of pasta to be more than 1.65 standard deviations above the mean. So now there are two ways of working this out. Some people, what they can do is that, let me grab my calculator because I have done it the other way. So how much is the mean? The mean is 2.5. So mu is 2.5. And this thing over here is 0.12. Standard deviation is 0.12. Let me multiply these two. That is 1.65 into 0.12. That comes out to be 0.18. So 1.65 sigma. This is 0.198. So 2.5 plus 0.198, let me add it, plus 2.5, that comes out to be 2.698. 2.698. So basically, they are asking us more than 1.65 standard deviations above the mean, probability x is greater than 2.698. So if I work this out and then I do the working, z is greater than 2.698 minus 2.5 divided by 0.12. So minus 2.5 divided by 0.12. That comes out to be 1.65. So this comes out to be probability z is greater than 1.65. Do you get this idea? So that is one approach if you deal with numbers. So let me just shift it down. Understand it once again. We have mu, we have sigma, we have 1.65 sigma, 2.5, that's the mean, plus 1.65 sigma is this much, and then you work it out. So you are left with 1.65. This, let's say, this is method number 2. I have done it using method number 1. What is method number 1? I'm working symbolically. That's mu. That's mu plus 1.65 sigma. X is greater than this value. This mu and this mu cancels out, this sigma and this sigma cancels out. So I have worked symbolically and still I'm getting the same thing. So this symbolically is the better way in my view. Z greater than this thing, that is rule number 2 that you apply. And then you get this value from the Z table, and then you subtract, and then you get this answer and make a habit of writing 3 significant figures because this is already rounded off. So now this thing is done. Let's talk about this one. Now, the masses of small bags of pasta sold by the company are normally distributed with mean mu and standard deviation sigma. So this is like that thing in which you have to solve simultaneous equations. Now it says test shows that 77% of these bags have masses greater than 1.26 and 44% have masses lesser than 1.35. So that is the second condition. And this one is the first condition. Read again. Probability x greater than 1.26 is 77%. Probability x lesser than 1.35 is 0.44. Now here is the problem. The minimum probability that is given in the Z table, that is 0.5 or 50%. So what do? We flip the inequality and subtract the probability from 1. So therefore, we will now be working with this thing. And then it's back to simultaneous equations. So now let me write it down. Probability Z greater than 1.26 minus mu divided by sigma is 0.77. Probability Z greater than something is 0.77. First thing first, since there is a greater sign, therefore there should be a negative over here. And for 0.77, the corresponding Z value from the table is 0.739. So this is obtained from the Z table. This is called back solving. What do we mean by back solving? That means using the probability to find the Z value. What is the probability? 77%. 0.77 is the P value. The corresponding Z value is 0.739. And you gave it a negative sign because of the rules that I have explained it to you in class. So now this thing is done. Now let me write it down. So therefore 1.26 minus mu divided by sigma is negative 0.739. So this is the first thing that is done. That is the first equation. Let me go to the next one, the blue thing. Now I'll write probability Z is greater than 1.35 minus mu divided by sigma is 0.56. Probability Z greater than something is 0.56. Again, it's a scenario of back solving. And now the probability value is how much? That is 56% or 0.56. And the corresponding Z value, also double check my working. The corresponding Z value is 0.151. 0.151. So therefore, again, a negative sign because of this greater, and this is 0.151. So therefore, what is the equation standardized? That is 1.35 minus mu divided by sigma is negative 0.151. This is equation number 2. So this is equation number 2. So this, let me write, this is equation 1. This is equation 2. And then we would solve it simultaneously. I think I'll make sigma the subject. That is 1.26 minus mu divided by negative 0.739. I'll make sigma the subject, 1.35 minus mu divided by negative 0.151. 1.26 minus mu divided by negative 0.739. That is 1.35 minus mu divided by negative 0.151. Get rid of these two negative sign, cross multiply, and then you will be getting the values. So first of all, mu is coming out to be 1.37 and sigma is coming out to be 0.153. Both answers are given correct to 3 significant figures. So let me just write this thing 0.153 a little bit neatly. That is 1 and 5 and 3. Okay, so that's how this question is done and dusted. Now we are on question number 7. I think that is the last question. And now it says a set of friends consists of 7 men and 4 women. So men are marked in blue, women are marked in green. 3 of the men are brothers A, B, and C. Part A, find the number of different arrangements. So this is permutation. That's 7 men in a line in which A, B do not stand next to each other. So now 7, it's just about the men. It's not about women. Okay? So first of all, let me write over here. This is only about men, the first part. It says, so out of 7, 2 are gone. So this is basically men 1, men 2, men 3, men 4, men 5. And A and B could be standing in any place in any of these gaps. So 1, 2, 3, 4, 5, 6. Out of 6, there are 2 possible places. And what about these men? They can arrange themselves in 5 factorial ways. So when you use a calculator, you get this answer, and this answer is exact. There is no rounding off. The second part, find the number of different arrangements. Again, NPR. Always make a habit of underlining. This is arrangement. So NPR and factorials. This is arrangement, NPR and factorial. So how many men are there? 7 men. How many women are there? 4 women, in which all the men stand together and all the women stand together. So this is like the box concept. All 7 men, 1, 2, 3, 4, 5, 6, 7 in a box, all 4 women in another box. So in the box, in how many ways can they arrange themselves? 7 factorial. How could the women arrange themselves? 4 factorial. But this box is on the left, this is on the right, so they can also switch places. So therefore 2 factorial for the switching. So 2 factorial for switching the boxes. So now when we multiply, we get this big number. Again, this number is exact, no rounding off. All got all clear? The third one. Now it says, in how many ways can the 7 women, so there are 7 women, 7 men and 4 women be divided into a group of 6 and a group, let me just change the color because it's not about man, woman anyway. So now it's about a group of 6, a group of 3, and a group of 2 if there are no restrictions. So first of all, how many are there? 11. So the order does not make a difference. So first of all, what I'll do is that from the 11, I'll choose 6. And once I have chosen 6, then from the remaining 5, I'll choose 3. And then the remaining 2 will be automatically chosen. Now, someone can ask this question, what if I change the order? Doesn't make a difference. Let me choose 11C5 first. How many are left? 6. Let me choose 6C3 and then 3C3. I'll get the same answer. Why? Because 11C6 and 11C5 is the same. And over here, out of 6, this is 6C3 and 3C3. They will give me the same answer as this. So let me double check. So there is not a group of 5, my bad. Let me just change one thing. So therefore, let me first choose, there is a group of 6, 3, and 2. So 6, 3. So let me choose 3 over here. And let me just correct myself. So there is a group of 6 and 3 and 2. So they have chosen 6, 3, and 2. Let me change the order. Let me first choose 2, then 3, then 6. So 11C2, how many are left? 9. 9C3, how many are left? 6. 6C6. Of course, this answer will exactly be the same. Again, this answer is exact. So in perms and coms, we always are working with exact answers. This thing is done. Now, the last part was a nice one. It says the 7 men and 4 women are divided at random into group of 6, 3, and 2. Find the probability A, B, C are all in the same group. Let's focus on the group of 6. So let me write over here. This is group of 6. Now, if we talk about this group of 6, first let me put in A, B, C in this place. So those three are there. 3C3 is technically 1. That means the out of the remaining 8, since I need a group of 6, I'll plug in 3. So 3C3 into 8C3, how many are left? 5. The remaining 3 could go. Let me choose the blue color. So 3 goes in the other group and then 2 goes in the other group. Let me change this color over here so that when you are reading it, there is no confusion as such. So let me get a stroke eraser. So don't confuse this color with that color. I think one of the color was changed. So now over here, got this idea? Group of 6. First fit in ABC. 3C3 is 1. Out of the remaining 8, fit 3 in. So group of 6 is formed. Then group of 3 from the remaining 5, group of 2 from the remaining 2. That's 560 ways of doing it. Now let's focus on group of 3. So out of group of 6, after group of 6, there is group of 3. So of course, only ABC will fit in. A, B, C will fit in. That group of 3 is formed. And then 8C6, what is this for? So 8C6 is for the group of 6 and 2C2 is the remaining group and there are 28 possibilities. What about group of 2? Group of 2, that is not applicable because there are 3 people A, B, C. So therefore this scenario is not applicable. So if I take 560, if I take 28, I add it up, that is 588. And what is the denominator? This thing, the number of possible outcomes, the denominator, that is the answer of part C. That's right over here. This is the answer of part C. So 588 over 4620, this comes out to be 7 over 55. And that's how this paper is done. This is May, June 2025, variant 53. And that was an S1 paper, a very nice paper. Take care, everyone. Stay tuned for more content on mathematics with Shahab Yaqub.